Good morning and welcome to Construction Philosophy's webinar. Topic of the day is crack-free concrete. Is it a myth? Our expert panelist comprises of Dr. Elton John, who is an MTech in structural engineer and a PhD holder from Indian Institute of Technology, IIT Madras. He is presently working as an associate professor in the Department of Civil Engineering at Mar Athanasius College of Engineering, Kodamangalam. His area of interest includes admixtures in concrete, special concrete, durability of concrete, etc. He has got 12 years of research experience and he got more than 35 publications in various international, national journals, etc. Presently, he is in charge of Research Center of KTU and MGU at MA College of Engineering Center for Continuing Education and Concrete Research Laboratory at Mar Athanasius College of Engineering. And he is presently the Secretary of ICA Coaching Center. And we have Engineer Surya Prakash with us. He is an MS in Structural Engineering from IIT Madras, the founder and mentor of Smart Infra Estate, a trust which is dedicated to the civil engineering to enhance employability and employment. He was the president of ACCI during 2013 and 15, and he is the founding president of PSI. And Engineer Surya Prakash is a FIE, FACCEI, MICI, etc. And he is the member of expert committee appointed by Government of Andhra Pradesh from June to October 2019 to review projects of irrigation, urban development, and R&D. And we have Mr. Anil Kumar Pillai, who is the GM of Technical Services of Ramco Cements Limited. He is the alternative member responding Ramco Cements Limited in the following committee of Bureau of Indian Standards, BIS, which is Cement and Concrete Sectional Committee, CED2, and Cement Pozzolana and Cement Additives Subcommittee, CED2:1. And we have Dr. Sunita K. Nayar. She's a visiting faculty at IIT Palakkad since December 2017. Prior to this, she served as a scientist at IIT Madras under the DST WOS program. She holds a PhD degree from IIT Madras in building materials and construction technology. Her area of interest is the characterization technique for FRC specialized in IRC SP46, largely based on her thesis. So welcome all to the show. To start with, I would ask Engineer Surya Prakash to come in. Sir, concrete cracking is a major cause of worry for all the building owners.
Yeah.
The causes can be different according to the situations, the scenario, the climate, and lot many factors. It can be due to workmanship. It can be due to settlement, temperature, design. All aspects can be taken into account. Can you tell us how to classify it?
Okay. So I'll be sharing my screen.
Yeah.
And I'll give a small slide presentation for 2-3 minutes. As you all can see, the cracks in concrete can be classified into two categories actually, basically. One is non-structural, that is the cracking due to bad concrete itself. So what we are seeing here is a bad concrete cracking. We can see on the screen. And other cracks in concrete are due to structural issues. I think today we'll focus, because it is a huge subject by itself, we'll focus on concrete cracks by itself. So we have main reasons for cracks in concrete or excess water in the mix. That means that water cement ratio used more than the design mix, and concrete drying too fast. That means due to dry climate or higher temperatures like summer in India, and improper strength concrete. That means the concrete mix that is not complying to design mix. And then lack of control joints. This is joints are we do have joints in the concrete because of the time taken for concreting. They're sometimes called cold joints, sometimes construction joints, sometimes working joints, and expansion joints, shrinkage joints. So many types of joints are there. And if we are not providing the joints required in the concrete, that also can cause cracking in the mostly in the floors, basically floors and large area of concrete. Then foundations. Whenever we have foundations casting during winter, due to low temperature also, the cracks can happen. So this is a crack being monitored. You can see on the screen the extent of crack in the floor, and we will dig into the crack and see the depth of the crack and monitor the progress of the crack also. This is the flooring, you can see. So now the causes for cracks in concrete are mixed design, compliance to the mixed design, whether it is aggregates quality, aggregate source, or cement quality and cement source, and then curing period and the type of curing, setting time. This is a major cause actually of what I have come across in the project. The ready-mix concrete, particularly, or concrete from batching plant, whenever we use the retarder, the design of retarder would not have been adequate, and then there should have been initial setting, and then we'll use the concrete which has set initially. That will cause the problems, and workability and spreading. Even the concrete compaction can also cause the problems if we don't properly compact, vibrate, or spread the concrete across. And then retarder, use of retarders in ready-mix concrete to delay the initial setting time. And then summer concreting. This is a major thing we face in dry climates, particularly in summer, when the quick setting happens and shrinkage cracks start forming even before final setting happens. So for that, the solution is to cover LDP sheet on as we pour the concrete so that evaporation is controlled and the proper setting happens. And then joints, pour sequence also has to be planned. Whenever we plan the concrete, to avoid cold joints in the concrete, we have to see that the cold joints are avoided and proper construction joints are planned. And then expansion, separation, construction, transverse movements in the floor. These are the causes actually. So we have to provide the proper expansion joint, separation joint, construction transverse joint, that is for the shrinkage actually. As per any code, you should not have a concrete panel more than 20 square meters. So, and also allow the movement in the floor, because most of the times we have these floors on a PCC. So due to friction at the bottom, there will be movement, and at the shrinkage time, there will be friction, movement in the top layer, and there will be cracks in the top surface. So we have to allow movement in the bottom layer of the concrete by providing a LDP sheet or a smooth surface. So these are the main reasons, and the concrete cracking can be so disastrous also if it is not properly done. This is a concrete where initial setting happened before pouring the concrete. And reasons other than concrete itself are detailing also. If the reinforcement is not provided where it is required in the mass concrete, particularly, all faces of the concrete should have the reinforcement, and also the laps. In some case, we have come across in a column in a government project, the column, all the laps are provided at the same level, and when de-shuttering happened, the whole concrete cracked in the column. So this kind of cracking can also happen. And the quality test before and after is also very important for the concrete. So slump test, particularly for the workability, and spread test in case we use the flow mix. These are the requirements of all the tests to be followed meticulously as per the caudal provisions. So finally, the quality assurance can avoid cracks, quality ingredients can avoid cracks, and quality workmanship. And more than all this, engineer has to engineer and the engineer has to do engineering. This is the main thing. And as we all know, for the concrete to be ready, it takes 40 days, 28 days for attaining its strength. And prior to that, preparation and all that, the aggregates, procurement, cement. So 40 days production time is not a small thing, and it requires proper monitoring to get the concrete that is properly attaining its strength and durable. So that's my thing. So thank you, Nebu, for giving this opportunity.
The opinion is really clear, actually. I would like to bring in Dr. Sunita. Dr. Sunita, basically, we have many aspects that, many factors that affect the cracking of concrete, and that includes materials as well. So since you are into materials, what kind of strategy do you think we have to adopt for bringing in a crack-free concrete culture in terms of materials?
Yeah, just let me share a small presentation that I have. I think that might help answering your query. So I hope my presentation is visible.
Yes.
Yes. Yeah. So good morning to one and all. I'm Sunita, and I'm a faculty of IIT Palakkad. My area of expertise is in building materials and construction technology, and my research is specialized in high performance concrete. Engineer Surya Prakash has set the platform clearly and well for discussion, because he's clearly told from the construction point of view what are the factors that contribute significantly to cracking. I think my role is here to contribute to the solution through research and academic findings, as Nebu has told. So from a materials perspective, most of the cracks are related to the low tensile capacity. I think I'm purely talking about what is the manifestation, what causes the manifestation of cracks in the material. So I think it is related to the low tensile capacity and the inherent brittleness in concrete, which leads to the cracking tolerance. Now, if you look at from a materials perspective, all the factors that Engineer Surya Prakash has said, if we convert it into a material concept, what can we attribute these crack is caused by? One is, of course, the inadequate design capacity, which is the load effects. The other one would be the long-term performance characteristic, that is due to restriction to free movement due to the dimensional instability. And I think one major factor that we have to consider is the deterioration mechanisms. That is, whatever is the crack caused due to durability related issues. So if we see in details, now this is one sentence that if you all know Dr. Kadiali, he always used to say, concrete is unforgiving. What he means is that if you do a mistake and the crack comes, then it's very difficult to cover it up. So you have to start thinking about this before you lay the concrete. I think that's what Engineer Surya Prakash sir was also emphasizing on, the quality control. So let us see from materials points of view, what can be done to improve the cracking characteristics in concrete? As I said, it's directly or indirectly related to the tensile characteristics. So one strategy would be to improve the tensile strength. Now this is something that I think we are all trying to do, but it's not always practically possible, increasing the tensile strength, because I think Mr. Anil will be able to tell what is the restriction in this possibility of increasing the tensile strength with respect to our binders. The other would be to improve the long-term performance characteristics of concrete. The characteristics that will be improving the durability, or the one of the major cause of crack, which is the corrosion. How to mitigate this corrosion? So if you can do this, the long-time performance of concrete can be improved. And then you can, all the cracks that are related to these characteristics, which are maybe due to chemical attack, acid attack, or corrosion, can be mitigated. The other strategy would be to reduce the stresses itself, such as reducing shrinkage stress, using shrinkage, reducing admixtures, or control dimensional changes due to thermal effects. This is something like neutralizing the curling completely, or reduce the temperature difference in the concrete, reduce the stresses due to temperature difference in concrete. So many strategies can be adopted from the material point of view. Another would be, which is commonly adopted in Indian conditions, is to do a conservative design. Use elastic methods, design methods, which take care of, which is over designed, or you use enough factor of safety such that the load, the crack due to load is always prevented. That would be another strategy. This is essentially adopted in most of our pavements, flooring and all. We essentially adopt these elastic methods and appropriate conservative design. Now, this is like, I'm asking, you're asking a question, how to control cracking from material point of view. This would be like asking, what can we do to prevent COVID-19 infecting us, isn't it? So the government is doing a lot of things. What is it that we can contribute? That's that question. If you can answer from our side, it would be like you increase your resistance to this virus, isn't it? That's what everybody is telling nowadays. Similarly, can we adopt a strategy that concrete itself has some characteristics so that the crack does not occur? Or you improve the crack resistance of concrete by improving its crack performance. And for this, one option, not all, this is not the exhaustive option, one option is to add fibers to concrete matrix. Because what fibers do is to improve the crack performance. What it does is, essentially, the fibers would bridge the crack. It does not mean that the cracks will not happen, but it means that even if it occurs, the cracking would be very limited in its crack widths, because the fibers would increase ductility, it would delay and control crack propagation and increase the tensile strains at rupture. All because of this post-cracking characteristic, which is demonstrated in the load deflection curve here. This blue one is for a plain concrete with almost very ductile failure. This one, sorry, the orange one is the plain concrete, whereas all the other three show some of a post-cracking capacity. That means it is resistive enough to hold the crack together. So that this is how fibers are distributed in concrete matrix. So that any direction a crack occurs, a fiber will be encountered and it prevents cracking. So let me just show you one example where these are two adjacent road pavements that are laid in one site. This is plain concrete and this is FRC concrete. Now you can see that there is a crack. Even in the FRC, you can see a crack. It's almost of the same age, but the crack width is so minor that you will not be able to, it does not affect the serviceability at all. So this is also possible. This is imparting an inherent cracking resistance capacity to concrete. This is one of the strategies that you can adopt. I think Dr. Elson will be talking a lot about the durability and long-term performance characteristics that you can improve of the concrete. I think that's what I have from my side. We can have a discussion.
Yeah. Thank you, Dr. Sunita. I would like to bring Dr. Elson now.
Let me stop sharing.
Well, Dr. Elson, these days the technology of manufacturing concrete have drastically improved. The term specific or special concrete has emerged in recent times. So how do you identify the need of or the choice of special or specific concrete?
Okay, thank you, Nebu. For that, Sunita and Surya Prakash was talking about the cracks and the remedies for that. So let us, for addressing this question, when we are talking about special concrete, we should understand what are the reasons for the concrete and where and when it is occurs. That is very important. For that, I also will have a small presentation. So I think I can share the video screen. Can you?
Yeah. Yes, go ahead.
So again, why concrete cracks? So as Sunita was mentioning, concrete crack occurs when the tensile load exceeds the tensile strength of the concrete. That is true for all materials, not just concrete. But the specialty with concrete is that concrete starts cracking before the strength attains itself. In the plastic stage itself, there is possibility of cracks. So if you are looking into the tensile strength, concrete is having a tensile strength. Let me take the pointer. Tensile strength. So the creep, shrinkage, everything will added, and the strength in the concrete the net tensile strength of the concrete goes up. So when it becomes equal to the or exceeds the tensile capacity of the concrete, the crack starts. So why concrete cracks and when? That's again a question. Concrete starts cracking when just finished and stiffening starts. That means plastic shrinkage cracks just after the final set. There can be disturbance, cancers, crazing, etc. So within a few days after setting, it can happen in several years after setting, like corrosion, shrinkage, and lots. We'll see which of the different types of cracks. So even some cracks can occur at a much later stage, even after decades. When I'm talking about the time depends upon the quality of the concrete, the exposure conditions, the ingredients of the concrete, lot other parameters are there. So the causes could be physical, chemical, or mechanical. So if we classify the concrete, the cracks in the concrete, broadly we can classify that into two. One is structural cracks and the other one is cracks in the concrete, material problems. So we can start from the broadening. So the cracks can occur before hardening of the concrete itself in the plastic stage of concrete. So the main problems are the plastic shrinkage cracks and plastic settlement cracks. So I'll show you how it occurs. So again, there's all the possibility, but most of the time we are neglecting. There will be formwork movements while moving the formwork or settlement of the supports. Again, for slabs on grade, there can be grade subgrade movement also that can lead to cracking on concrete. So after hardening, there are many reasons for the concrete to crack. One is the physical reason. So again, drying shrinkage of the concrete. So that is due to the evaporation of the water from the or removal of water from the concrete, and that can be structural crack also to most of the cases, even though that is happening in the material level. Then crazing of concrete. Then there can be chemical reasons for the cracks to occur, corrosion of the reinforcement, alkali aggregate reactions, cement carbonation. There are other chemical reactions also like sulfate attack, chloride attack, etc. But that won't make cracks in the concrete many of times. Sometimes sulfate attack may come, but that will disintegrate the concrete. So what I'm concentrating here on the cracking. Then there can be thermal reasons for the cracks. One is freeze-thaw cycles. So in cold regions, freeze-thaw can lead. Then thermal contraction and expansion. Then early thermal contraction cracks. And in addition to that, there are structural reasons for that. Accidental overload like fire, earthquake, etc., creep. Then the design loads. So let us see some of the types of cracks, how it occurs. Plastic shrinkage cracks that happens within few minutes can start within few minutes after the concrete base and go up to the initiation of the hardening, few hours. So we can the plastic settlement cracks. So in the first stage, concrete is saturated. So the water will bleed out, bleed to the top. The solid materials will have a tendency to come down. So all the other parts except over the reinforcement, the material is free to settle down. So above the reinforcement, there can be a tensile stresses develops and you can see the cracks, then subgrade changes, then drying shrinkage, that is removal of the water from the pores in the concrete, then thermal, because for that's especially for the mass structures, the inside temperature in the concrete will be high and the surface it is exposed to atmosphere. So there will be a temperature gradient. So that can lead to cracking. Then sulfate attack, alkali aggregate reaction. You can see map-like cracking in the structure. Again, corrosion of the reinforcement. When the reinforced steel corrodes, its volume will expand. That will exert pressure on the concrete, and that can lead to cracks and spalling in the concrete, freeze-thaw resistance, thermal cracks. So this is a very interesting figure. So we can see the different types of cracks in a particular structure and see where it is occur. So where these plastic settlement cracks are occurring on the reinforcement, there will be a ring-like reinforcement in that, in the longitudinal as well as horizontal direction. So the cracks can occur here. Again, there is a reinforcement. So you can see that below that part of that reinforcement, concrete can settle. So again, we have the plastic shrinkage cracks. This is also plastic shrinkage cracks. These cracks are due to the tension. Because of the loading, tensile cracks can propagate. And these are temperature cracks. So in mass concrete structures, if there is a superimposed load, this will not crack in the vertical direction, horizontal direction. So the temperature cracks will be in the vertical direction, but in the understrained areas, it can be the horizontal. We can have the alkali silicate aggregate cracks. We have the trying shrinkage cracks, and these are the cracks due to the corrosion of reinforcement. It's a very big topic, so I'm not going to much details of that. So in actual structure also, where we can see lots of cracks when you are going into the field, I will show you a picture from a recently constructed building in Cochin. So it's a 750 square feet flat, and they have drawn very nice pictures. It's not an artwork. They marked 68 cracks on the bottom side of the crack with chalk, and they numbered it. You can see that 37, 38 like that. And on the top surface, they found almost 130 cracks. So mainly because of the disturbance and the plastic shrinkage cracks, and some of the cracks are extending through the concrete, and you can see the water is percolating, their line cracks and to the defected areas. So the cracks is a usual issue. So crack is like a cancer in our concrete. If we can find out and repair it at a proper time, we can extend the service life of the structure. Otherwise, it is very dangerous. So always prevention is better than cure. So with this, each of the times we have to address, when you are talking about special concrete, different types of concrete. So for initial stages, we have to reduce the temperature. So we have lots of admixtures to address this value. Mineral admixtures are as well as for chemical admixtures. But for each of the case, it should be addressed properly.
Yeah, generally the cracks are not seriously taken and it is ignored. Most likely covered with plaster, paint or something actually.
Yeah, that's it.
So it's advisable to have always have an expert opinion when you find a crack, even if it is a small or big crack.
Yeah.
Mr. Anil Pillai, the cement industry now had introduced many special kind of cements, like quick setting or sulfide resistant, or many different types of cement with different characteristics. Do you have a product specifically for reducing cracks?
Now, I think good morning to all of you, and most of you have covered the real reasons of cracks, and it is very difficult to be the last speaker when most of the reasons have already been covered. See, in simple terms, when we look at the real reason for crack, this particular word crack, in fact, when we use it in our daily terminology, also it irritates many people. And it also gives sleepless nights to many civil engineers when it happens. So, as rightly pointed out by Dr. Elson, in prevention is better than cure. That is one thing. In simple terms, when you see, when the stress in a building component exceeds the strength, that is when it cracks. So the stress can be induced due to different reasons. It can be externally induced, maybe because of load and things like that. It can be due to seismic load. It can be due to dead load, live load, or it can be due to internally induced stresses due to which cracks can happen. Now, as far as cement is concerned, when you look at cement, cement reacts with water and hydration happens, due to which heat is liberated. And now due to this excessive heat, there can be a problem in concrete. So we need to use a cement which is having a low heat of hydration. That is very important. And most importantly, there is a code for handbook of cracks, SP25, which in fact lays down the different types of cracks, and wherein they have clearly recommended that a cement with low heat of hydration is recommended for concrete to avoid cracks. Now, when you look at cement with low heat of hydration, you can see the types of cement. It is basically the blended cements, the Portland Pozzolana cement, the Portland slag cement, which can be used for reducing the heat of hydration when compared to ordinary Portland cement 53 grade, which is having a very high heat of hydration. So that is one thing. Second thing is that the chemical composition of cement can also be fine-tuned in such a way that, all those attacks, say for example, you have the sulfate attack, you have the chloride attack, you have the alkali aggregate reaction, the carbonation can be taken care of. And that is where the role of blending material, role of PPC comes into play. That is where we in the cement industry, what we have done is that we have been able to introduce various types of cement. Like say, for example, if you have a Portland Pozzolana cement, one thing that is being spoken by many of the users is Portland Pozzolana cement is having a low rate of gain of strength. So how do we use it? That was one of the main concerns that they had come about with. So we had the challenge of giving a cement which is having both high strength as well as low heat of hydration. And that is where you will find that Ramco Supercrete, we have been able to bring in wherein the compressive strength is also taken care of and heat of hydration is low, and that is where we are able to give you concrete with the probability of cracks is much lesser. So what do we do for that? What we have done at Ramco Research Development Center is that we have studied heat of hydration in detail. If you look at the cement test certificate, heat of hydration is not at all mentioned, but heat of hydration studies we have done, and we have done durability studies using RCPT and water permeability test, which takes care to a large extent many of the deterioration mechanism that is happening in concrete. So to that extent, we have made some kind of this thing. I would just like to share my screen to just show you what are the kind of studies that we have done, so that it would give you an idea of what kind of heat of hydration studies we have done at our research center. Now, if you look at these are different types of cracks which have already been covered, so I do not want to repeat the same thing. This is something like sulfate attack which is happening.
Sorry, we are not seeing your presentation.
Screen is not on.
Yes, now it's okay. Now,
No,
is
we
it?
are seeing
Yes, sir. We can see the slides.
Yeah. Now this is what Ramco Supercrete cement, wherein we have been able to achieve all the cohesive concrete. What Surya Prakash sir was telling is about the mixed design part of it. Now, in the mixed design, if we are able to make a cohesive concrete with required workability and
Mr. Anil, actually, sorry to interrupt. See, basically, your screen is not popping up. Actually, it's.
Is it visible now?
No, it's just the folder.
Oh, is it?
Yeah.
It's not visible.
No.
So I will just explain to what we have done, so that in terms of durability studies, we have done this RCPT test wherein we have checked the amount of charge that is passing through the concrete specimen. So in case of ordinary concrete made with ordinary Portland cement, we have seen that the amount of charge in coulombs is much more. It is greater than 3000 coulombs, which is considered to be a concrete of low durability. Whereas concrete made with PPC or blended cements is having a low charge that is passed through the specimen, which indicates that the concrete is having high durability. So that is one study which we have done. And water permeability test also indicates the durability of concrete, wherein instead of charge, you pass water through it and see how much of water is permeated through that thing. So this kind of studies help us to understand what Dr. Elson has just mentioned about the deterioration mechanism of concrete. And that is where you will find this blending materials comes into play. Now, this is what you're able to see the graph.
No, nothing yet.
Nothing yet. Okay.
Only the folder.
All right. The heat of hydration also, we have seen, we have compared ordinary Portland cement heat of hydration with PPC, and we have found it is to be much lesser. The temperature scanner experiments that we have done at research center, again, it has shown that the maximum temperature evolution, when you use OPC 53 grade is much higher as compared to Ramco Super grade. So that is one thing why we are able to recommend Portland Pozzolana cement to many of the works for reducing the cracks. And another thing which we have observed is during the interaction with construction professionals is that areas which are very hot are more prone to cracks. And such areas, they need to give special attention to curing and to ensure that the concrete doesn't dry out. Most of the reasons due to shrinkage, say for example, you have the plastic shrinkage, you have the drying shrinkage, you have the shrinkage due to chemical, and those reasons, autogeneous shrinkage in case of high grade concrete can be avoided if we follow the practice of timely curing as well. So this just gives you a brief overview of which cement is better as far as reducing crack is concerned. But then to sum up, I think it is not only the quality of material that is important, it is a holistic approach that needs to be followed. A combination of material which is having low heat of hydration, good construction practices, adequate curing practices, and a proper concrete mix design, wherein the total fines content in the concrete is reduced. The total fines, if it is reduced, the water content in the concrete, that much, the probability of concrete getting cracked is lesser. So this is just an holistic approach, and I just mentioned about the salient features of the cement that can be used for reducing crack. So that's it from my side. If I'm able to show you the screen at a later point of time, I would be able to enable it.
Yeah,
so that is as far as the cement perspective is concerned.
Thank you, Mr. Anil Pillai. Actually, I want to come back to you, Engineer Suri Prakash. So you mentioned many terms like the cold joint, staggered labs, etc. Can you please elaborate those terms, because the layman could also understand this, the normal public.
We call any joint in a concrete as a cold joint when the gap between two pores of concrete is more than the initial setting time. Normal initial setting time for OPC concrete is 30 minutes. Nowadays, we are making it 1 hour, 1.5 hours by using retarders. And when we plan the concrete pouring, we are using pumps or manual pouring of the concrete. And then we go in a particular sequence of pouring the concrete. And when we go back to another position and start pouring, if the gap at the last tail end between the previous poured concrete and the present pour is more than initial setting time, then it is called the cold joint. That means we cannot meet two concretes which have set initially. One has set initial setting and the other has not yet done, so it cannot join. Certainly there will be a crack in the cold joint. So we have to treat such cold joint. If we know beforehand that if it happens by design, we have to give the treatment of the cold joint in the concreting. Otherwise, we have to avoid these cold joints by planning proper pour sequence for the concrete, so that the gap between previous pour and present pour is not exceeding initial setting time. That is cold joint.
And about the lap, staggered lap, actually, which is, almost all the time, actually, people tend to ignore how the lap have to be provided. And that could be a major cause for cracks as well.
Yeah, in fact, many of the people, it is very difficult to plan staggered laps in the columns particularly. And even for staggered laps, there are detailing requirements for the spacing of the stirrups. We have to reduce the spacing of the stirrups at the lap position, because there will be more bursting tension at that position. And I have come to know that recently in a government project also, people have left, because it is difficult to plan. It is easy to cut all bars of the same length and leave them. And then they have used even the couplers at the same position. They thought that lap provision of the code caters to only the development length lap. Lap is a lap, whether it is a coupler, crimping, or development length. Any lap, it is we have to avoid at the same position, because there will be increase in the bursting tension at that position, and there will be cracks in the concrete, and it can be catastrophic, because column is an important element in the structure, and we are going to suddenly load the column when we do the de-shuttering. When we suddenly load, there will be a tension developed, and concrete is a brittle material, and any failure in concrete will be sudden. So it is very dangerous. So we have to avoid, this is a detailing, important detailing requirement when we talk about cracks in concrete.
All right, Dr. Sunita, actually her video is not showing up.
Yeah, I just muted it, that's all.
Yes.
Yeah.
Basically, Dr. Sunita, actually, you mentioned about a product. We have many solutions for one single problem these days. Actually, we have, in terms of material or methodology or a practice, we have many solutions. As you mentioned, actually, FRC can be one solution for a crack-free concrete. So, how best is the solution, and how feasible is the solution, and how economic is the solution? Is it possible for the normal house builder to use this particular technology?
Yeah, so FRC, I would not call it as a product, it's a technology.
Yeah.
Now, whether you want to use it depends on the project. Okay. Now, for a house, for a normal construction house, it depends on what are the requirements of the concrete. That is, if you can manage with improving the characteristics of concrete without fibers, such as ensuring good durability, crack resistance, by adjusting the mix proportions itself, then you don't have to essentially add fibers. Fibers becomes very critical in cases where there is a severe ductility requirement, such as seismic loading or beam column junctions, or cases where you want to avoid additional reinforcement or supplementary reinforcement where there is a lot of congestion. In such cases, adding fibers will add to the ductility as well as it will take care of the crack control, crack issues. So it should be application based. For example, one application where you could invariably use fiber would be slab on grade applications, such as flooring, pavements, because those are the applications which are governed by the flexural strength characteristics. Most of the other designs are governed by the compressive strength or the stress strain behavior. If it is controlled by the flexural strength characteristics, then it is recommended to use fibers. Now, if you are talking in terms of shrinkage alone, that wherever you have a large exposed surface, to reduce shrinkage, fiber is definitely one option. But the economic implications are high. If you see, for let us say M35 concrete, I mean, for a meter cube of M35 concrete, how much would it cost? Can anybody give me an answer to that? An M35 plain concrete.
Approximately 8,000 rupees.
No, lesser than that also. If it is an economic, if it is an economic mix, I think you can go up to 6,000, 7,000 rupees, because if you are using blending material, it all depends on the percentage of fly ash or blending material that is being used.
Yeah, but the fiber reinforced concrete for the same grade would come around 13,000 to 14,000 per meter cube.
Almost double.
Yes, almost. So that is the reason. Depends on the fiber also. Depends on the dosage and fiber. This is a general, like less than 0.5% of volume fraction. If you're using steel fibers, it should come around this range, this cost. So that's why I'm saying that it's not a solution. It's not the one-stop solution. You have to use it wisely.
Dr. Elson, see, when you say specific concrete, the special concrete, how do you identify the areas where a special type of concrete has to be used? Is there any particular criteria that you follow?
So one is where Sunita was talking about now, fiber reinforced concrete. The other one is self-compacting concrete, when you are talking about. So sometimes the reinforcement will be too congested. So there won't be even no space even to concrete to, or the needle vibrate to go in. So sometimes the formwork may be too complicated. So in such cases, we can use self-compacting concrete, which even don't want any vibration at all. The concrete will flow its own. And whenever there is a problem with this thermal cracks, we can go for blended cements like Anil Kumar sir was talking about, adding fly ash or GGBFS or any mineral mixture. Or in mass concrete, in order to avoid this thermal contractions, we can go for high volume fly ash concrete, where we can use almost 50 to 70% of fly ash. So again,
I mean, sorry to interrupt. I mean the kind of concrete, the special concrete which can resist reduce cracks.
Reduce cracks.
Yes.
For example, if in the normal concrete with the OPC, instead of that, as Anil sir was talking about, if you are adding a fly ash, what the advantage is, the long-term strength can be increased. In the same time, the initial heat of hydration can be reduced. So the cracks in the initial stage, cracks in the initial stage due to the thermal effect can be reduced. Again, we can go for high-strength concrete or alter the water cement ratios. We can add special type of admixture. For example, for reducing the shrinkage effect of concrete, we can add the shrinkage reducing admixture in our concrete. Actually, special concrete is a broad term for the specialized applications. But we can make our concrete special by adding admixtures into the concrete in our normal concrete itself to reduce the crack or to prevent the crack.
All right. Actually, the normal house builder is always skeptical about uses of admixtures or additives. What is your opinion? Is there any adverse effect in using such chemicals or materials into concrete?
If you are thinking about a quality concrete, you need some sort of admixture in that concrete. Because if we are asking who is the enemy to concrete, water is the most dangerous enemy to concrete. So whenever you are adding more water to the concrete, the problem starts there itself. So for a quality concrete, the water content as well as the cement content should be made as low as possible to get the required performance. I'm specifying that time, the required performance, that in terms of strength, workability, and durability. So when you're adding more water, what happens that for a complete hydration of the cement, the water cement ratio required, if you are considering the inner pores also, is 0.42. If you are taking a cement grain, the water cement ratio required is only 0.4. But when you are considering the pores inside that structure of hydration products, it's only 0.42. For a main household work, if you are going for a site mix, the water cement ratio, if you are not using an admixture, the water cement ratio will be always more than 0.6 to get a workable mix. Even our IS code specifies the maximum limit of water cement ratio as 0.55, even for M20 grade concrete. But for a site mix, we won't get a workable mix without any admixture. So normally the water content will be much more. So when more water is there, what happens? That water will be in the concrete itself, and that water will be evaporated to the atmosphere due course of time. So all the moisture, chloride, sulfate, all the deteriorated components will percolate the concrete. It start disintegrate the concrete and start corroding the reinforcement. So for a normal concrete, superplasticizer is a must. Superplasticizer is the chemical which will reduce the water cement so workability without increasing the water content. So we can increase the workability or get a workability with a much lower water cement, water content by using a superplasticizer. In the same time also, mineral admixture. When the cement react with the water, it will produce CSH and calcium hydroxide. This calcium hydroxide will not produce or give any binding property. So if you are adding a fly ash or mineral admixture, that will react with this calcium hydroxide to produce additional CSH, which will give you much more binding. So this reaction is little slower, as Anil sir was mentioning, but we can make our concrete as per our requirement. We can do the mix design and get the strength at any stage as per our requirement, and that will improve the strength as well as durability in the long term.
It is always better to use ingredients to refine our product.
Yeah.
Well, I'll come back to Mr. Anil Pillai after a few questions. Actually, we have a few questions from our participants. Mr. Bruno Tayo has asked this question. Actually, I'm passing it to Engineer Surya Prakash. What physical tests can be carried out on site to assess the cracks? Engineer Surya Prakash. The general, yes.
That is after the cracking or?
After the cracking, maybe, actually, yeah.
Actually, any crack that is observed at the site, there cannot be any generic solution. I have seen some participants asking questions, can I inject, can I do application of epoxy, all those things. Like we go to a doctor for any problem, it is better to go to concerned engineer. Any problem that is seen in the concrete in the form of cracks or any bad concrete, we have to refer it to the engineer with the incident report we call, like how it happened from the engineer's point of view at the site, and what are all the reasons and when it happened, how it happened, all that we call it an incident report. So we get an incident report from the site, from the engineer in charge at the site, and then we study that incident and identify the root cause for the problem. One is to avoid such problems in future solution. Next is to immediately solve what has happened. So if we find cracks in the wet concrete, that is before final setting, the good thing is to pour the cement slurry afresh on the surface. That can go and restart the chemical process. Otherwise, if we have found the cracks after final setting, then it needs to be analyzed. Is it due to shrinkage? Is it due to temperature, quick setting, or is it due to the joints? What is the cause of the crack? We have to identify, and for each cause, we have different solutions. So we'll never attempt a generic. So I see in many projects, when we visit the site after decentering or after the concrete, when there are cracks, they will use the mortar and cover it up, a cosmetic treatment. That will not solve the problem. As Alson said, for the durability of the concrete, we should not leave defective concrete as it is. We have to rectify it by understanding the depth of the problem. So there are many solutions actually, like injection grouting, applying the bonding agent, filling with epoxies, and filling with even cement slurry. Like that, there are many solutions. But
Engineer Surya Prakash will come back to the solutions.
May I just interpret? I think the question is also about assessing the cracks.
Yes.
I think, there are...
whether it's a structural or a non-structural crack, that has to be
first of all, it has to be classified. Actually, is it a structural or non-structural? We'll come back to that.
That is the first thing that needs to be seen.
Again, one more thing, whether the crack is live also. Strategy should be different for proper crack and a developing crack.
And even in terms of width of crack,
more dangerous. So
before coming back to before getting into that technical aspects, actually, I would like to bring in Mr. Anil Pillai also into the debate. See, basically, we have to understand one more thing actually when you talk about crack, because heat again is a big factor. So again, Mr. Ashish Dange has asked the question relating to that. What is the heat of hydration different from OPC 53 and 43?
Yeah, now see, as far as 53 and 43 is concerned, there is no specification in the cement code. In fact, for any cement code, if you look at the cement code of OPC 43, OPC 53, PPC, PSC, there is no mention about heat of hydration in the codal provisions. Like say, for example, in IS 269, IS 1489 or IS 455, they have not mentioned. But what we have done is that we have measured the heat of hydration in our laboratory for OPC as well as PPC after 7 days. Now you will find that OPC, PPC after 7 days, there is a huge, in terms of, in some cases, we have found almost 15 kilocalorie per kg difference. Like say, for example, if OPC shows 50 kilocalorie per kg, your PPC would be around 40 or 35 after 7 days. So that is the kind of heat of hydration difference that we can see with respect to different types of cement. But within 43, 53, there is nowhere it is mentioned that heat of hydration is lower. In fact, that is a very important question. Most of the government works are, specifying OPC 43 grade, thinking that OPC 43 grade would be having a low heat of hydration as compared to OPC 53 grade, which is not the case. So ordinary Portland, if you want to use a cement with low heat of hydration, go for a PPC cement. Or otherwise stick to ordinary Portland cement and you blend the cementitious material at site. So that is another solution which can be a practical solution, which many of them are doing. Especially ready mix concrete, you will find that they are blending fly ash at the site itself. And one more question was there regarding whether fly ash can be used for high grade of concrete. In fact, it can be used. Why? Because if you look at IS 456, the maximum cement content that is specified for any concrete grade is 450 kg per cubic meter. Now, if you want to increase the cementitious material beyond 450, what do? You have to add cementitious material. So blending material is very much applicable, and you cannot make high grade concrete without using this blending material. Beyond M50, M60, you have to use it.
I have one question in this. Doctor, my understanding about 43 and 53 is the difference in the fineness of the cement, isn't it?
No, even the fineness also, if you see, it is both the fineness, it is mentioned is 225 meters per kg in the code.
But then how is the difference in the grades?
The difference now, what they have made the difference in 43 is that 28-day compressive strength, the minimum compressive strength of 43 grade mortar is 43 MPa. maximum is 58 MPa. So they have brought in the maximum limit of compressive strength for 43 grade. Whereas for 53 grade OPC, the minimum is 53 MPa, there is no maximum limit. So that is the only difference that is specified in the code.
Yeah, I am not talking about code, but theoretically the difference between the two grades is the difference in the grinding. No, the fineness is more for the higher grade.
Correct. That is it. At the end of it, what happens is that we have to fulfill that requirement.
Yeah, so shouldn't the heat of hydration be different actually when the fineness is higher?
Even earlier, that higher limit for the 43 was also not there. It came in an amendment.
Exactly. In the recent amendment only they had made it.
It is more than for 33. We can't say that whether it is 43, 33 or 53. The upper limit was there. That recently they made an amendment to the code and they implemented it.
Exactly. Now this thing is that if it goes beyond 58 MPa, it is no longer a 43 grade cement.
Right. Right. Well, talking about cracking again, actually coming back to the subject topic, the temperature has a big influence in cracking of concrete, actually the deterioration of concrete. So how important is to maintain a particular temperature at the work site during concreting, Dr. Elson?
So it's a very difficult thing, because the problem is that there is a variation in the temperature from season to season. So we are, for a big project, we are designing the concrete mix and we are using the same mix design throughout the year. Even in a day itself, there is a lot of variations. Even the night, if you are doing a concrete, that will be 18 to 90 degrees centigrade. And in the daytime, it may be 35 degrees centigrade. So this variation itself can lead to lots of problems. So it is very difficult to handle that issue. One problem is that try to do the concrete when the temperature is low, but that may not be always possible due to practical considerations. So one of the major issues with that, the dosage of superplasticizer. So at higher temperature, we need a higher dosage of superplasticizer. So normally that issues we are not taking into account. So that is why at higher temperature, the plastic shrinkage cracks, everything is high. So our concrete should be done.
Dr. Elson is having a technical issue, it seems. Engineer Surya Prakash, let us go back to the previous session actually to identify how do is my voice audible?
Yeah. Yes. It's
Engineer Surya Prakash. Yeah. How do we classify the cracks actually, whether it is a structural crack or a harmless, or how do you classify it? How do you identify it?
This is a very interesting phenomenon actually.
Sorry.
Yeah.
Go ahead.
We had one site where we found cracks exactly following the pattern of yield line in slabs post deshattering.
Okay.
So we were really worried that they're all structural cracks. When like if you have a 4 supports 2-way slab, so there is a trapezoidal shape of cracking that we observed. Then we had to do the real investigation. Why I am telling this is never come to a conclusion by seeing the crack that it is a structural crack or it is not a structural crack. So that's why I always tell my people on site to make a report. How we make a report, if it is a slab, for example, let us collect the data of the levels, 4 supports and span. If there is no deflection in the slab, there cannot be cracking due to structural things. So if we avoid deformation issue, then it is a non-structural crack. That is how we can make. Similarly, columns, for example, column, you collect the dimensions of all the 4 sides and whether it is a rectangle or not, measure the diagonals and measure the verticality and check whether it is structurally proper or not. First establish that, then you can come to a conclusion whatever cracking is there is not due to structural reason. Once you establish it's not due to structural reason, then you handle it as a non-structural crack. If it is a structural crack, then go into the analysis of the structural loading, what it is designed, and concrete strength, reinforcement, tying, all these things we have to analyze. So for diagnosis, this is a diagnosis of the problem. It is a big subject by itself, and we should not leave it to any engineer supervisor grade at the lower level, because we have to understand all the parameters of the concrete: columns, beams, slabs, foundation, retaining walls. These are all in buildings and in bridges and all we know. So we have to first confirm or rule out that it is a structural crack. That is very important. If it is a structural crack, treatment is different. If it is a non-structural crack, then what is the reason? We have to go to the basis of crack due to excess cement, excess water, shrinkage, temperature. These are all and the detailing can also be like no cover also can cause cracking. So we have to establish that, and we have to, most of the sites, the problem I see is design mix actually. I have come across some engineers showing me design mix on WhatsApp, and that too, it is only in text format. That means it's not a signed document. So please, engineers should insist on proper mix design with accountability from a responsible lab or institution actually. That's very important. And then there should be accountability if the mix design is. And in the mix design, most important is to mention the sources of material and grades of material properly. Whether it is aggregate, gradation, fine aggregate, zone, and then cement grade and source of the cement, all these things, specification has to be very clear in the design mix. And for those materials, you mention the mix, and on site, you confirm the conformance of these design mix parameters in the batching plant or mixing. So this is first step in the concrete to avoid. That's what I said, compliance to the design mix and the design mix proper. And next is making the concrete. Once we maintain the parameters of the design mix, the only problem can be site conditions varying from the assumptions of the design mix. That means whether it is a temperature, humidity, suppose there is a sudden rain in the site, then it varies from the design mix. So you have to seek the changes from the design mix concrete expert, what should be the changes, and then incorporate those changes. Otherwise, due to rain, there can be some problems in the site. Then refer it to the engineer, design engineer, and take the method statement for rectification and do the method, implement the method. So this is the process to be followed.
Right. Do you mean?
Can I hear?
Yeah. Yeah. Yes. Actually, you were saying something. Yes. Go ahead. Go ahead. Yes.
So can I continue that?
Yes. Yes. Yes.
So what I have to tell is, one is make sure that the concrete is having the proper workability. So when you are using a superplasticizer, the dosage should be adjusted accordingly when the temperature is. Again, you can go for cold water. You can use in the concrete, you can get some ice and you can maintain the temperature of the water so that the total temperature of the concrete can be reduced. But when you are getting an ice, you should be careful about from where you are getting that ice. It should not have any chlorides. Many sometimes if you are getting from the fish market or somewhere like, it may contain chlorides. So that will start corroding your reinforcement. That should begin. Again, at hot climates, you have to start curing your concrete as early as possible, because the plastic shrinkage cracks will be starting early. So you have to keep the concrete, and after hardening also, you have to keep curing your concrete, because if the concrete is exposed to high temperature initially, the hydration will be fast, the strength will be more. But what happens is that its microstructure will not be proper. So there will be lots of pores inside that concrete. So the durability of the concrete should be much lower. So you have to start your curing and ensure that the temperature of the concrete is not going up. So these are the normal things which we can adopt in our sites.
Well, it's already 1 hour, but still, actually, I wanted to go back to Engineer Surya Prakash once again for the solutions, the maintenance, what we can adopt actually, generally, what we can adopt actually. The audience would be really interested to hear it from you, sir. Engineer Surya Prakash. The mitigation methods.
Mitigation of cracks is to prevent. That means follow the quality process. And even if you follow the quality process, why the problem can occur is because of the mismatch between the conditions assumed. environmental conditions. Somebody also raised that point. Environmental conditions assumed in the design and environmental conditions at the site being different. So we have to mitigate such changes that are happening in the process, incorporating in the process. What should be the change mechanism in the mixed design in case there is a difference in the site condition, number one. Number two is, in spite of all this, the cracks occurred in the concrete. Then I said there should be a methodology of assessing the cause, identifying the extent of damage, and whether it is live or further progressing also we have to establish, and then we have to start giving the solution for such cracks. And always for non-structural cracks, there are many easy solutions like filling the crack, using the epoxy, grouting, and all these are okay. But when it is a structural crack, then it requires a proper rehabilitation. We call it rehabilitation or strengthening measures. If the structure has not attained the target strength, we have come across many projects where target strength is M40. The average strength achieved, the 28-day strength achieved, is 14 or 16 in important columns. We have come across such things. Then what we do is we completely ignore the concrete that is available in the column. We provide jacketing for such columns entirely, ignoring the strength of the existing concrete. That is because important column, because robustness of the structure depends on the strength of these columns also. So then we have given the entirely new column encompassing the old column. That kind of solutions also are possible. And in slabs, when you have, so I am only talking about the cracking due to lack of strength in concrete only. Steel, I'm not talking now. So if the slab concrete doesn't attain the strength, then we have done the strengthening by using the metallic strips. Like we confine the concrete with the metallic strips or carbon fiber or even the gunneting or shotcrete we do below the slab by providing a fresh mesh of reinforcement. Here we use even welded wire mesh and stitch it to the existing concrete through shear lugs and then do the shotcrete. And sometimes we have even made holes into the slab and then poured the concrete by putting the shuttering below. So this kind of multiple solutions should be adopted. Sometimes we use the structural steel support, joists. We introduce the joists. Sometimes we even introduce the like flat slab capitals, structural capitals to reduce the span by, so depending on how much shortfall we have in the concrete. So that is for structural solution. So non-structural, I explained, whenever, if you have a through crack in the concrete and it is non-structural, means it is because of the concrete being used after setting. If whether it is in columns or slabs, that needs to be fully grouted with epoxy because the pores will be less and that concrete is totally ineffective. It requires total strengthening. So we have to identify such a major problem. It is a major problem. Whenever we have used the cube strength will be all right, but if you do the core test, it will fail. That means the concrete cubes are taken fresh from the transit mixer and the concrete is used after setting. So this is one of the major causes we are observing of late in the last 20 years in the concrete.
Dr. Sunita, are you there?
Unmute. She has to unmute.
Yes, yes.
Yeah, in terms of materials, the same question. In terms of materials, how do you assess that situation? I mean, how do you find a solution for it?
That's what I think that's the starting of the discussion of Dr. Elson, where he says that prevention is better than cure. So you are talking about after the crack occurs, or how to prevent cracking?
After the, yes.
After the cracking itself.
Yes.
So I think there are a lot of grouting techniques which are being marketed by many manufacturers. Most of these are very good techniques. You are talking with respect to concrete cracking that has occurred, no?
Yes.
If it is due to corrosion, then it is a serious issue. You have to actually remove the corroded bar, insert another bar, and then only you have to wear the structure. So it depends on the problem. If the problem is due to a specific, to address that problem, most of the time it is important to address the cause of the problem. What happens is generally people tend to ignore the cause and they just find the solution then and there. This might not be a sustainable way of solving that problem. First, let us say if you have a leakage, you have to find out from where is the leak or what has initiated the crack. Solve the crack cause itself. From the material point of view, that's the only way of solving this issue.
All right. All right, Dr. Sunita. Dr. Elson John, in terms of, again, in terms of material, actually the admixtures, use of admixtures or additives or any agents, how do you make sure that those things doesn't happen? Actually, the crack, can be, cracks to be minimized during the construction stage itself, on-site, I mean.
So one thing, in order to avoid the crack, the design should be proper. Then we have to select the right material. There can be different admixtures, but we have to take the right product for that. Then the right mix is in. And the construction methodology also should be followed. Again, for example, if for plastic shrinkage, normally that's a very common thing in our areas. So it will happen if you are using an OPC in our climate in that time. If you do the concrete will have plastic shrinkage cracks, and that will be high if you are going for a low water cement ratio. So we have to take the preventive measures also for that. For example, sprinkling the water after that or covering the concrete. And for restricting the plastic shrinkage cracks, what we suggest and the more effective what we are seeing is just covering it with a plastic sheet. Now the thin plastic sheets are available in the form of rollers. When you start and finish the concrete, keep it on the one side when you start. So as your concrete process, you have to roll that, just like for the we are making the roller paper on our table, roll it out. So immediately after you are covering the concrete, so the water will not evaporate from the surface of the concrete. It will get condensed on that concrete and the cracking can be prevented. Again, you can start the curing over that because this mixing water will not be mixed with the water in the concrete as there is a plastic cover. So whatever material you are using, whatever process you are using, the construction process also very, very important. Again, if you are talking about long-term shrinkage cracks, drying shrinkage cracks, we have admixtures available in the market. Lots of brands names are available. If you add that chemical in your concrete, it will reduce the surface tension of the water. So removal of the water will be less. It will not exert much stress on the concrete, and we can reduce the plastic shrinkage cracks. So what we require. So again, now the concrete, what we are talking about now, the strength of the quality of the concrete in a structure is assessed by cube test. And we are doing the concrete and taking the cubes. And cubes will be properly cured and tested. But what happened to the real concrete in the structure? It may not be compacted properly. It may not be cured properly. So the quality of the concrete in the cube and the structure is entirely different. That's why now we are talking about the performance specification of the concrete. We are no longer interested in the cube strength. We will take a core from the structure, or we will cast sacrificial elements along with the structure, and cores will be taken and tested that for strength as well as the durability parameters like chloride threshold, permeability, etc. So that strategy has to come because we should monitor what the properties of the material, because we are designing for M35 grade of concrete, and as rightly Surya Prakash sir was mentioning, we are believing that it is M35, but sometimes it may be only 25. So the cracks will propagate. So selection of the right material and the right procedure and to monitor the mechanism is very important in restricting the cracks in concrete.
Once again, Mr. Anil Kumar Pillai, basically you have mentioned a product which is a crack-free cement. So what is the solution actually? How do you rate it actually in terms of economic, the cost effectiveness and how feasible is it for this purpose? Can you please briefly explain?
Yeah, in brief, if I would go about that, in fact, when we started manufacturing Portland pozzolana cement much earlier, there was this perception that Portland pozzolana cement may not be having high rate of gain of strength. That was the initial thing. Okay, you are taking care of durability, the free lime is taken care of, CSH gel is there, all that is all right. But what about rate of gain of strength in PPC? So that was the feedback that we had received. So based on that feedback, we had formulated a cement which is having a high compressive strength as well as low heat of hydration. So that is one thing, because many of them are going in for an economical concrete mix proportion. And when you talk about economy, I think one of the more primus requirement is compressive strength. So that is where in our Ramco Supercrete, we have been able to maintain both compressive strength as well as durability parameters, so that the economical mix is taken care of. Now, one more point, Engineer Surya Prakash sir has already rightly pointed out the importance of concrete mix design and defining the concrete before the mix design is done. That is what we also do. When we go to the customer, rather than specifying the type of cement, we just try to understand the concrete requirement. Now, based on the concrete requirement, we specify the type of cement. So we ask them what is the slump retention, what is the compressive strength after 1 day, 3 days, 7 days, and are they going to use some chemical admixture? If they are going to use chemical admixture, what we would always recommend is that do a trial mix using that particular admixture and the type of cement that you are using. Because until unless you don't do the trial mixes, you will not be able to know whether you are getting the required slump retention and the compressive strength. That is why we have always propagated this idea of having a right product for right application, get the concrete requirements correctly, have a clear communication. And one more thing is that what Dr. Elson was just pointing out, we should go for the performance specification, not the prescriptive specification. So you specify what is it that you want, you know, how much compressive strength, what is the target strength that you need, and all those parameters. So I think a combination of all this would be helping in helping the customer to make a concrete which is crack free. And that is what we have been offering in our Ramco Supercrete cement, a combination of good properties of blended cement and a higher compressive strength of OPC. So that is a blend of both.
Nebu, can I tell you one more thing in that?
Yes, go ahead.
So that's one of the common doubt that we are hearing from the site, whether to go for OPC or PPC, or which cement is better, 43 or 53. Again, that depends upon the applications.
Correct.
So if for a residential building, which cement should be used? Because what's the difference is the rate of gain of strength. If you are going for a 53 grade of cement, the early strength will be higher. But if you are going for a 43 grade, earlier strength will be less. But what's the advantage is that for a 43 grade cement, the heat of hydration will be less. So for a normal building, if you are not interested in a high early strength, we can go for the lower grades of cement so that the heat of hydration can be reduced. And always people are going for 53 cement without looking into application, because when they are hearing that 53 grade, they are feeling that the 53 strength is high. But the point should be noted that whether it is 43 grade or 53 grade, we are designing a concrete for M25, 25 Newton per mm square. So either we use 43 or 53, our strength in the concrete should be 25. So that should be. Again, for OPC or PPC or blended cement in general, always, as I told you earlier, cement will react with water to produce CSH and calcium hydroxide. So when you are using PPC, means that it is nothing but OPC plus fly ash, maybe 25%, in and around 25%. Right, sir?
Yes, it is between 15 to 35%.
Yeah. So
normally 25-27% is
will be the cement content. So when this fly ash is adding, this will react with the calcium hydroxide to produce additional CSH, which will give you better binding. So always for the normal purpose of going for a blended cement is advisable. But for some special applications like precast industry, or whenever you need a yearly removal of the formwork, you can go for OPC or 53 grade cement.
That's what a very important point, because for precast industry, we have a different type of cement, as rightly pointed out by him. What we do is that we look at the early removal of formwork in precast. That is more critical than any other parameter. So we need to identify which parameter is overriding all other parameters, and based on that, we need to specify. I think that's a very important point that was made. And another thing is that heat of hydration is not mentioned in many of the IS code. That is one of the lacunae that we see. So heat of hydration has to be measured in the laboratory for different cements, because it all depends on the chemical composition of cement as well. That is very important. I think that is one important point.
Well, the topic is very vast, actually, that, a couple of days wouldn't be sufficient to address all issues and the solutions, actually. So, in fact, we are running short of time. We have to wind up now. I believe that the discussion was truly informative, and considering the views shared here, we would strongly recommend an expert consultation while choosing a product for your building. The viewers can contact us at any time for any specific queries or any support with regards to construction. On behalf of CP, Construction Philosophy, I would express my sincere gratitude to all the panel members and all who have spared their time attending this session. And those who couldn't attend the session can watch the recorded video, which will be published later. And thank you so much, the panelists, Mr. Anil Kumar P., Engineer Surya Prakash, Dr. Elson, Dr. Sunita. So we will see you again. This is just a beginning. We'll see you again with some other topics. Thank you so much.
It was a pleasure talking to all of you and interacting with all of you. All the best. Thank you.
Yes, same here.
Good day.
Yeah, have a good day. Thank you.